being nice, sort of. I'm trying to be nice. All right, we're going to be doing a specialist exam paper. That's what we're going to be doing. We're going to be doing a specialist exam paper. We are going to be essentially doing the 2021 Tech Free paper. I don't even know the multiplication things, let alone the letters. Yeah, look, this is pretty difficult. This is the hardest course in Australia. That's where these questions are coming from. So I totally understand. I'm gonna write hard math, bracket maths, depending on where. I guess everyone here should be like Australian or UK based on the time zone. So wait, I can just put the S in. This is hard maths. This is just about the hardest of the maths. So we can start. We actually can start solving questions. We got 7 people here, so that's pretty good. So we can start by looking at the very first question. The very first question we have is an inverse tan function. Okay, not to be confused with the reciprocal tan functions, which look very similar. When I look at your profile, I just remember that your vids were the ones that helped me in calculus. Oh, thank you very much, Anne. Well, we're going to be doing some calculus here, just some hard calculus. We can see part B, if I zoom in here a little bit on part B. Part B, we have some differentiation. So if we are looking at the very first question, let me just move some of my windows around so I can actually read everything correctly, because we're sort of doing things through the computer a bit today. If I have a look at the very first question, we have, let me get this up as well, that way I can see everything that's going on. Okay, so as I fix my windows. Okay, so we have the very first question is an inverse tan function. We are looking for suitable values between, we're just looking at part A. So if you can't read all of part C, that's okay. But just look at part A. We have an inverse tan function. We have tan to the negative 1 of x over 2. X is, or the function is between negative pi on 2 and pi on 2. So we have a bit of a domain here for what my angles could represent. If we do something like this, the first question is actually something that we could really solve if we do like lower level maths. We've got function notation. We're substituting in the value of my function when x equals 2. If I do that with my function, if I put the value of 2 in, and I'm going to try to write the number 2 like a proper human. Let me zoom in a little bit. Okay, f of 2. That is equal to tan to the minus 1 of x over 2. If I put f of 2 in, wait, that's meant to be a highlighter. If I do f of 2, that means I'm simply just putting 2 in place of my x. So instead of writing x here, I simply am just going to write the number 2. We'll change color to make that really clear. Okay, so we replace the letter x with the number 2. We now simplify our fraction, and all of us hopefully know that 2 goes into 2 once. So when I get tan to the minus 1 of 2 over 2, that gives tan to the minus 1 of 1. If I have tan to the minus 1 of 1, well, what angle gives an answer of 1 for a tan function? That is going to be pi on 4. Okay, so the first one, part A, it's 1 mark. If I zoom out here a little bit, hopefully you guys can see that there. It is a 1 mark question, so we weren't expecting to do a whole lot. I thought I'd go through nice and slow whilst we're just sort of getting started here, and I'm warming up a little bit as well. I've got my pink water bottle here, so make sure we stay hydrated, everyone. We get an answer of pi on 4, and if we have a look, right, the value of my function should be between negative pi on 2 and pi on 2. Well, a quarter fits perfectly between minus a half and a half. So everything's kind of working out. If you guys have any questions, feel free to fire them away into the chat, and I'll do my best to answer those as soon as possible. If we come down to part B, I have the derivative of my function. And again, I want to find the value at 2. So it looks very similar to part A. The difference is at this tiny little dash there, that tiny little dash means I'm now differentiating. So I want to differentiate my function. For those of us that aren't aware, if I have my function is tan to the minus 1, we normally use the rule of x over a. My rule for differentiating a function like this is going to be that I get a over a squared plus x squared. That is normally the rule for my derivative. So, if this is my rule for my derivative, a in this question is going to be 2. Again, if I know the rules, so much of mathematics, people do get stressed out about rules sometimes. So much of mathematics gets easier if we understand the rules, because then we can just plug numbers into whatever our rule is. I'm going to put my little rule
I might just put it there, and I'll change the color. Can I change the color of this? There must be a way to change the color. Where's my dots? Okay. Where's my color change option? Let me circle it again. Haha, colors. Let's make this in orange. So, there's my little rule there. It's nice. It's in orange. I can now use my rule based on my question. My question is x over 2, so my a value is 2, which means my derivative of this function is simply just 2 over 2 squared plus x squared. Well, 2 squared gives 4, right? 2 squared is going to give 4. I'm going to replace this number with the value of 4. Okay, so I've got my function. Once I have my function, I simply just need to sub in my value of 2. Again, everywhere I have an x, I'm going to put in the value of 2, and I've got myself my answer. Okay, I've got myself my answer. And I'm going to do my best to respond to the chat, but there is some chat delay, so apologies if I take a few seconds to reply. So if I put 2 in place of my function, I'm going to scroll across here just a little bit. I'm going to zoom in just a touch to try to put my answer, try to squeeze it in the corner here. If I do f dash of 2, that simply equals 2 over 4 plus 2 squared. That equals 2 over 4 plus 4. 4 plus 4 gives 8. I get 2 over 8. That simplifies down to 1 over 4. Apologies if my writing is super small. Hopefully we can all see that clearly on the screen, or clearly enough, hopefully, on the screen. So, all right. I'm going to bring my microphone a little bit closer. Hopefully that way I'm nice and clear to listen to. So I've got these two values for part A. For part A, I have the answer of pi on 4. For part B, I've got the answer of 1 on 4. If I come down to part C says, using the results from questions 11A and 11B, determine the equation of the tangent to the graph at x equals 2. Okay? So I'm trying to determine my equation of the tangent at x equals 2. Parts A and parts B have both given me some very important values. Okay? In part A, I found essentially a coordinate point. I know from part A that when my x coordinate is 2, my y coordinate is pi on 4. Okay, so that's what part A tells me. Oh, we got some questions in the chat. Sorry, I took a few seconds there. Hello, everyone. What is your best advice for preparing for CU questions for the QCAA methods besides from using Exam Insights? I'd recommend following my TikTok. I will do some exam paper stuff, and I'll talk about some thought processes. I actually have quite a lot of ideas around the methods CUs. I've been very fortunate to teach some very bright students in Queensland specifically that have done very well, and talking to them about strategies they've used and also what I think makes sense. In my opinion, best advice preparing for CU questions is going to be to get very good at your question initiation. So essentially just reading a bunch of questions and trying to get a good idea of what the question's asking. Okay, so we really want to be focusing our fundamentals a lot throughout the rest of term 3. That way when we get into that sort of holiday break going into term 4, we can actually start preparing more on how we're starting problems instead of worrying about how we're finishing them. I'd say that's where I would start. And there'll be, I mean, I could go do a whole hour live just on CU advice. So maybe I'll trickle some more in. We're going to get to CUs in the specialist paper. I'll trickle some more advice on how to actually unpack the questions when we get there as well. So feel free to stick around. If you plug 2 into f dash of x to find the m and then plug 2 into the original function, that's the equation. That's pretty much correct, right? And we've already done that. Like part A and part B, we plug 2 into the original function. You can see there in part A. Part B, we plug 2 into the derivative. So we have our gradient from part B. Part A gives us our coordinate point. All we need to find the equation of a straight line, which is a tangent, right? A tangent is just a straight line. All we need is a gradient and a coordinate point. We got it, right? Get a gradient, get a coordinate point, we can find any straight line. So if we come down to part C, I'm going to highlight this. We get our coordinate point. That is from up here. That is from part A. I know when x is 2, my y coordinate is pi on 4. I know pi on 4 feels like a yucky number, but it's not too bad in this type of question. Is this for year 11 prelims? This is specifically for year 12 specialist maths. This is the end of high school exam. The hardest course in Australia, really. The VCE version of specialist probably is the actual hardest course, but it's in that same sort of tier. So, coordinate point, that's the big thing I've highlighted in green.
Gradient, that is the thing I've highlighted in yellow. I'm going to draw a big arrow to it. There's our gradient at y equals 2. Or my gradient when x equals 2. So, to find my equation of a straight line, I know, I'm going to zoom in a little bit, okay? I know, well, there's a few ways actually to find equations of straight lines. I do it a slightly, sorry, that's meant to be plus c. I do it a slightly different way to how you may have been taught. So, I'm going to start with sub in m equals 1/4. That is from part B. I'm just going to put a little part B in brackets there so we know where I got that number from, and it doesn't look like I've just plucked it out of thin air. This looks like, I mean, year 10, any tips for me? Yeah, I'd say year 10, I would really focus on your algebra skills in particular. That's what really is going to carry you through in the later years. This looks a lot like some New South Wales yearly paper questions I saw. I don't know if I have to practice this. Depends on which part, right? Like all this stuff in part A and part B where we have an inverse trig function, we're substituting in values, we're differentiating an inverse trig function. That is year 12 mathematics. Finding the equation of a straight line, that is year 10 mathematics. So like the part C part, if you know part A, you know part B, part C really should be pretty easy marks in the bigger picture. So once I've got my gradient, I now go on to substituting that number in. That gives me y equals m is 1/4. That is 1/4 x plus c. I know my coordinate point I found from before. I'm going to use, pink's probably the best color in the world, right? I'm going to use 2 comma pi on 4. That is the coordinate point I found in part A. If I substitute that in, well, pi on 4 is going to go in place of my y. That is equal to 1/4 multiplied by 2 plus c. That is going to give pi on 4 equal to 1 plus c. So c simply just, oh sorry, I did a half. That's wrong. It's 1/4 here. I nearly got the answer. Nearly made a mistake. I wrote down the wrong number. That is over 4. The answer to that is a half, and that's where my mind went. Apologies. Can I do transformations and dilations of trig graphs? Of course I can, Toby. We can do that at some point today as well. So just stick around for that. I'm going to finish the specialist paper, and then we'll definitely do some trig stuff. I think there's actually trig stuff in this paper, so I can talk about some of the transformations when we get to that question as well. So I get pi on 4 equals a half plus c. This is a tech-free paper. I do not have a calculator. I can't get a decimal answer here. My only choice is to leave things in exact numbers, and we love exact numbers as math teachers. So I'm going to scroll across here. I get a value for c of simply just pi on 4 minus a half. Now, I'm a very big fan of making common denominators. Some people consider it overkill. We're going to make common denominators here, though. Okay, so I need to sort of resize and get myself a little bit more space. So I'm just going to kind of grab this top part here. That was really just setting up the question. I'm going to make this top part a little bit smaller. If you want me to make it bigger again, feel free to let me know. I'm going to resize this, make it just a touch smaller as well. Grab this, bring it down here. Okay, so I've got this part. C equals pi on 4 minus a half. I want to make everything over a common denominator. I'm simply just multiplying top and bottom by 2. I wind up with c is equal to pi minus 2 all over 4. Common denominator. I'm a math teacher, so we love doing things like this. I've got my c value. This might be overkill, to be fair, but once I've got my c value, I can now put that back into my equation. I get y equals 1/4 x plus pi minus 2 all over 4. Again, I've got 1/4 is common to both, so I have some options here. I don't think it necessarily requires this, but I'm always a fan of practice everything we can. What note/draw app to use? I'm a big fan of GoodNotes because it's just very easy to use, John. So I would recommend GoodNotes is really great at storing notes. That's good at storing notes. So that's probably all you need to know in terms of the name really says it, doesn't it? So I'm going to put this in a general form. Not necessarily, didn't say to. So for this question, it's 2 marks. We're probably fine. But I feel like practicing, everything to the end in this revision phase is really important. And understanding how to get different things is really important. So to put things, I've got a common denominator of 4. When I see we've got the same common denominator in both spots, we are simply just going to multiply everything through by 4. Okay, we're going to multiply everything through by 4 on both sides of my equation. I'm going to shrink things again because, like I said, 2-mark question, we're doing all the little nitty-gritty bits. So we probably could have saved ourselves a bit of space and not gone all the way, but we are just going to. If I times everything by 4, I get 4y is equal to x plus pi minus 2. Okay, so if I now if I now rearrange everything general form, things tend to equal 0. I want to bring everything across to my... Well, I like to keep x positive, right? X, y, c equals 0. So I'm going to bring my y, actually. I'm going to subtract 4y off each side. And I'm going to get a final equation of x minus 4y plus pi minus 2 is equal, if it lets me scroll across a touch, is equal to 0. Can we all... Did I fit all that in? Okay, I did fit all that in. Look... I think I could have stopped earlier. It's a 2-mark question, but that would be how we would make it into general form. And again, when we have a tech-free paper, I know this looks, maybe to our eyes doesn't look great. This is actually exact form. It is perfect. We're totally fine leaving solutions like this. Okay. So anyone have any questions about question 1? If not, I'm going to scroll across to question 12. We can start reading question 12. Question 12 is all about vectors. I'm going to have a sip of water whilst you guys read through question 12. I'll obviously read through it as well. Okay. Question 12. We have a plane. I love planes. We've got a plane. So, consider the plane. X minus y minus 2z equals 15. Determine a vector n that is perpendicular to the plane. This is very like vector theory. Sorry if the click was really loud. This is vector theory 101. Okay? I should know. Can you go over differentiating trig again? I wasn't there when you did it. Okay, so to differentiate the trig function, I'll quickly take a step back for hi with all the eyes, because you asked a question, and you know, if anyone asks a question, I will answer. I'm going to zoom in as much as I can. This is the rule to differentiate. Specifically, I'll put the other bit in orange. This is the rule. I just use pink because I've got pink ready. This is the rule. I know it's a little bit, there's a thickness issue here. This is the rule to differentiate tan to the minus 1 of x over a. Ooh, let's kind of fit that in there. So to differentiate this trig function, in the question here, I was given that my a value is 2. So I'm simply just putting 2 in place of a, which means I wind up with 2 over 2 squared, so 2 over 4 plus x squared. That is what I got there. That was the derivative. It's actually a pretty simple differentiation to do for the simple familiar questions. There's some algebra tricks that can make it a little bit more complicated, but ultimately, it's like most things in calculus. Once you learn it, like it's not bad. It's actually not bad. I know it's specialist and that freaks people out, but I would say in specialist maths, all the core foundational skills aren't really any more difficult than a course like methods. It's really just where those ideas can lead to that can make the questions harder. But the actual core concepts, I think, are just as easy to understand, especially if you like maths like I do. If you like maths like I do, yeah, it's all not too bad. So we'll go to our vectors. With our vectors, like I said, this is Vectors 101. I should recognize my normal vector comes from the coefficients of my x, y, and z. So my coefficients of x is 1. So my normal vector, we can write this a few different ways. I'm just going to choose to write it like a column vector. My coefficient of x is 1. My coefficient of y is minus 1. My coefficient of z is minus 2. Ding ding, 1 mark. Just reading out the question, we got 1 mark. I don't know how the clicking sounds in your ears. I hope it's not too loud. So that's A. It's as simple as that. I should recognize a vector. My normal vector is perpendicular. That comes from my coefficients of x, y, and z, of course. My right-hand side, that 15, that kind of gives us the position it sits in space. That kind of tells me how far up, how far down it is, kind of where it sits. Do I have some sheets of paper here? Okay, so I've got a sheet of paper. Some rustling. N value, normal vector, that's perpendicular. Okay, that is perpendicular to the plane. So something like this. It's kind of like the gradient of we kind of get the gradient of a plane based on the normal vector. Do you do extension 2 math? I do all math. Yes, extension 1, extension 2. Specialist is extension 1 and 2 combined. That's what this is. It's extension 1 and extension 2 rolled into a single course. So here's my plane. Planes are 2D. They're like sheets of paper. My normal vector is kind of like the gradient of a plane. Boop. The way we get the gradient of a plane isn't the actual slope. We take the perpendicular slope. And that's because mathematically that is an easier thing for us to find. And is this advanced or standard? This is specialist. This is extension 1 and 2 combined. Essentially, if you're in New South Wales, extension 1 and 2 combined. If you're in any of the other states of Australia, then you know it's specialist. So there's my perpendicular plane. What my n value does is it basically shifts it up or down. Okay, so my coefficients of x, y, and z give us kind of how my slope, the gradient of the plane, the slope of the plane essentially. My 15 just kind of shifts it up or down, right? The gradient changes, and then the n value is kind of my vertical translation. Probably the easiest way to conceptualize it. We can go deeper. That's probably the easiest way to conceptualize it. So, can you give a dot product question? If there's a dot product question in here, which seems likely, then we will definitely cover that. If we just finish off this one first, and I can do specific questions as we go along as well. Determine the vector equation of the line that is perpendicular to the plane and contains a specific point. Okay, so we want to determine the vector equation of a line L perpendicular to the plane. Determine the vector equation of a line. Okay, so we want to determine a vector equation of a line. I know I read that out a few times, but when we're doing specialist questions, especially the vector stuff, reading a question multiple times is important. There's an echo. Can you fix that? An echo. Okay. An echo. An echo. Let me see if I can fix my echo. Maybe I'm talking too loudly. Maybe that's the issue. Okay. Just looking at my microphone settings. No echo on my side. There's no echo. Oh, okay. I'm going to keep going then. I'm going to bring my microphone a bit closer, and hopefully that helps. It's better? Okay. If I shout, it can be a little bit loud. That probably makes things a bit worse. Okay, so vector equation of a line. Vector equation of a line is simply just R. That is R is essentially my set of points that form on the line. That is equal to any point on the line, plus, that's okay, feel free to let me know any issues. I'd prefer to fix it. Plus, T, which is kind of like your x coordinate for your straight line, and D. Okay, this is actually very similar. I'm going to give you a sort of an equivalent for those that are new to this idea. It's kind of like C plus x multiplied by m in y equals mx plus c, where D is your gradient, C is your sort of like your y-intercept, your point on the line, and then x is kind of T in this case. We can use different symbols, right? Sometimes lambda is used and things like that. X is just sort of like your generic algebra point. Do I need special 1, 2 to do 3, 4 in VCE? Do you need specialist unit 1 and 2? That's a school-based decision, to be honest. I think look, anything's possible. It depends on what kind of student you are. You're definitely putting yourself up for a very big workload. So, oh, nice. Okay, I'm glad it sounds perfect. Okay, good. So, if I consider all that information, right, I know A is my y-intercept. That is a point on my line. My point is given in my question. My point is this point here. D is my direction. So we're trying to find the vector equation of a line, L, that is perpendicular to the plane. That means it has the same, if it's perpendicular to the plane, it has the same gradient, the same slope as my normal vector n from part A. So really, I've got all the information I need. I'm just plugging in numbers, right? This is simple, familiar. So we're not, hopefully this is things that if we know the theory, we should be able to get the answers right relatively easily. A comes from the question, D comes from my normal vector, that is 1 and minus 1 and minus 2, sorry, not 2, minus 2. That's my answer. That is literally my answer. I do not need to do any more. Do I do foundation maths? I do all maths. Yes. Hey sir, hey Wobby. I do all maths, so yeah, foundation, of course. If you have any foundation questions, feel free to ask away. Okay, so we found our vector equation of a line. Again, that's just essentially, if we know the theory, the original stuff shouldn't be too hard. 25 finished VCE 7 years ago, didn't even do specialist maths. Well, if you're keeping up, then you're doing a fantastic job. So, if we want to use the results from question 12b to express the equation of the line L in parametric form. So parametric form is really where I get each part of my line. I basically am going to break it down. So I'm going to expand my equation here. I'm going to expand this equation, okay? If I expand my equation, then I can essentially get like a function for x, a function for z, and a function for y. That is probably the best way to explain what's going on. So if I expand kind of this side of things, one way I could write all of this is
my equation R, I don't know why I changed to green. My equation R is going to be given by, that is, it's probably the best way to do it, right? Okay. I've written these as column vectors, so I probably need to explain a little bit about what the column vectors part means before I jump into it. A column vector is a very neat way of writing out minus 2x plus, in this case, it'd be y plus 3z. Okay, so if I consider that, as it is, right? That means I could technically write this first column vector here. I could write that as being minus 2x plus 1y, right? The 1 being my coefficient from there, plus 3z. And then for my t part, that is going to be plus, in this case, it is going to be tx plus minus ty, and then it's going to, I guess I don't need to write plus minus. And let me just, I need to probably fix this a little bit. Let me grab and shrink here. Let me grab all this and we'll shrink it slightly. Okay. And I'll pull this back across so it looks a little bit neater. I'll bring this back across to here. And then if I expand the last bit, I get minus 2t. For this last part, I get minus 2tz. Okay. Using ijk when using vectors. Oh, that's true. I guess that's actually true. Yeah, I mean, I was just thinking because I get functions for x, y, and z. That's a good point. That is a good point. We can put this in ij's and k's. That's probably better. Okay, this is going to be I. This is going to be j. This is going to be k. And then I got I. I've got j. I've got k. So if I kind of get if I collect like terms, if I get my coefficients of I, my coefficients of j, my coefficients of k together, if I group all these terms, I wind up with minus 2 plus t, I. For my j, that is going to become plus, I've got 1 as my coefficient of j, and then I've got minus t as my coefficient of j over here. I probably should do some highlighting to explain a little bit better about what I'm doing. I'm basically taking my coefficients of this term, I'm putting them all into one bracket, because these, kind of collecting like terms, right, these are both components of my j vector. So, if I do that, I then do the same thing with my k's, right? I collect my coefficient of k here is 3, and I've got minus 2t here. That is going to become plus 3 minus 2tk. And I kind of group all of these parts. I'll use different colors, right? I got my I coefficient, my j coefficient, my k coefficient. All these little bits in brackets become the parametric form of my equation. Basically becomes x is my coefficient of I. So x is going to be simply equal to minus 2 plus t. Y is my coefficient of j, that is 1 minus t. And z is my coefficient of k, that is 3 minus 2t. And that is my parametric form. It is just the coefficients of my I, my j, and my k. And if I do that, I've got my answers. I didn't need to do all the expanding stuff. That's really just me trying to explain and kind of clarify what's going on. You could have just jumped straight to your answer and you would have been fine as well, right? You could have gone straight down to x equals 2 or minus 2 plus t, y equals 1 minus t, and z equals 3 minus 2t. So, let's go down to part D. The line L and the plane intersect at point S. I want to show specifically the point of intersection is 2, minus 3, and minus 5. Okay, so I'm trying to show specifically that my point of intersection is at these points. So all I'm doing when I'm kind of proving some kind of parametric equation is I'm simply just putting, if I scroll up, I'm putting these values. I'm going to get rid of some of my highlighters so I can kind of re-highlight and hopefully it'll make sense, okay? I'm going to place, I'll use blue for x. I'm going to place this minus 2 plus t. That is my value of x. I'm putting that in place of my x here all the way back into my original equation. I'm then going to take my value here of 1 minus t for y. I'm going to put that in place of y in my original equation. And I'm then going to do the same thing for z. I'm going to take this 3 minus 2t here. I'm going to put that in place of z in my original equation. So if I do that, I wind up with, it was simply just x minus y right at the beginning. So that's going to become minus 2 plus t. I can put it in brackets if I want, and I can put a 1 out the front, just so I can demonstrate that technically if you have like coefficients of these
values. They do exist, okay? I'm going to have minus 1 if I just continue putting coefficients there. Again, I don't need to because the value is 1, but just to help explain, 1 minus t goes in place of y. And it was minus 2z. That becomes minus 2, and z is going to be 3 minus 2t. And all of that still is equal to 15. If you can see all of that there. Again, I don't necessarily need to put these ones out the front, but just showing, like, if I had a 3 or a 4, minus 7, whatever, that would go there. If I sort of expand all my brackets and I collect all my like terms, I wind up with minus 2 plus t, minus 1 plus t, minus 6 plus 4t, all equals 15. I now want to, again, collect. I've got t plus 4t. If I grab all my t's together here, right, I've got t plus 4t. That is going to give me 6 lots of t. So I get 6t. And I got minus 2, minus 1, that's minus 3, minus 6, that gives negative 9, all equal to 15. I can now add 9 to both sides. Divide both sides by 6. 15 plus 9 is going to give 24. Divide both sides by 6, and I get a value. Again, I probably need to grab and shrink things down here a little bit because I am writing nice and big. That way we can all see. If I shrink this down here a little bit, I wind up with an answer or a value of 4 for my t value. Okay, so I get the value of t equals 4. Once I've found out, like some ways to conceptualize this is like, the point of intersection is at 4 seconds. Based on my parametric equation, the line and the plane are going to intersect at 4 seconds. That's one way to kind of think about this. You do get some time sort of added in here with the vectors. That's why t is quite a common variable, but t isn't necessarily time. It just sometimes can be time. Okay, I'm glad you think this is so nice. So, once I get t equals 4, I simply just put that back into my parametric equation for x, for y, and for z. So I'm going to put this value of 4. To clarify, I'm putting this value of 4. I'm going to draw a nice big arrow. This value of 4 is going to go into here. It's going to go into here. And it's going to go, if I scroll across a little bit, into here. And I should find, if I put 4 into all 3 of those values, I should get 2 minus 3 minus 5. And that then shows or demonstrates the whole purpose of this question, which is proving that the coordinates where the line and the plane intersect is 2 minus 3 and minus 5. So if I do that, if I put 4 in, I get, and actually, one way you can kind of help demonstrate this idea, and this is one way I've seen people do to kind of make this a bit clearer, is I could essentially list my coordinate points as their parametric equations. So I could say my x coordinate is minus 2 plus t, or in this case it's minus 2 plus 4, comma, my y coordinate is 1 minus t, that is 1 minus 4, and my z coordinate using my rule from above is 3 minus 2 multiplied by 4. And I can use another bracket there to kind of help clarify all of that. And I'm kind of zooming around here a little bit. Apologies if the window's shifting too much. So, minus 2 plus 4, that gives 2. Works for the first point. 1 minus 3, that gives minus 3. Ding! Works for the second point. And 3 minus 8. 3 minus 8 is going to give negative 5. Tick, works for the third point, and I've now demonstrated, I've now proven that 2 minus 3 minus 5 is the point of intersection between my line and the plane. Does that make sense? Do we have questions about this? Are we happy? Making sense? Have a sip of water. See if people are with me. Okay. Whoa, they gave me all that space. I guess that's why I had to resize a bunch. I still could have kept going on the next page, though I didn't. We have part E now. I want to determine. Specifically, I want to determine from A to S. Happy? Nice. What the hell is TS? TS? TS. TS. Where did I write TS? Is my writing messy? Did I mess this up? Wow, what a... Oh, thank you very much, Em. I appreciate that. I'm going to let my wife know that people called me a beautiful human being. That's right. That's right. Someone's got to say it. All right, so if we determine the line from A to S. From A to S, that is final minus initial. He's pulling your leg. Perfect. Thank you. If we determine the line from A to S, that is final minus initial, that is vector S minus vector A. I guess I could have used the capital A because I used the capital A here, but I guess we used lowercase a when we described the vector. Meanwhile, I can't even do methods in the minute. I think, as a quick tangent before I jump into this, I do think that sometimes with mathematics, like our brains are still developing all throughout high school, and I would say that I think most students would be able to do methods if that was the only thing they did in high school. If they just did maths in high school, you had one course, you just did methods, I think you'd actually be able to keep up relatively easily. But it's just the load. You know, it's all the different math courses, it's everything that's going on outside of school, it's, you know, you might be doing 6 subjects in year 11, there's so much stuff that goes on. I failed essential maths, is that okay? Of course it's okay. Look, I know people that didn't do super well at maths in year 11, year 12, and then went to university, did more maths through some tertiary education, went into university, and were fine. What state is specialist? Specialist is in Queensland, Victoria, South Australia, Western Australia, pretty much every single state. Northern Territory, I'm actually not 100% sure what their system is. Tasmania, I believe, uses specialist as well, but I could be wrong. Pretty much everywhere except for Canberra and New South Wales, in my mind, is specialist maths. So, determine the line A to S. I know S comes from the question before, right? S is this point. It is 2 minus 3 minus 5. So I can say that S is going to be, if I write it here, it's going to be 2 minus 3 minus 5. Minus point A. Point A was what we had here in part B. So both of these two vectors were actually given to us. They're specialist in Canberra. Oh, okay, that's good. Yes. Okay, so pretty much everywhere except for New South Wales uses specialist. And I would love New South Wales to use specialist as well, because I just think the system is better, in my opinion. It's the equivalent of extension 2. It's the equivalent of extension 1 and 2 combined into one course. That's what specialist is. New South Wales just wants to be different. Yeah, New South Wales does want to be different. I've taught in both states. I do think the specialist system is better, just in my opinion. The syllabus is very similar, subtle differences, but in the other, like New South Wales is also doesn't use any technology really, where other states also have graphics calculators, which gives them more scope within their syllabus. So it's mostly the same content, but in Queensland, Victoria, South Australia, Western Australia, these countries use graphics calculators. So I would say it's a little bit more advanced in terms of what questions can ask you, but you also have the tech to assist. So overall difficulty is about the same. All right. To tie back to the question, A is given in part B, S is given in part D. So I'm really just putting in numbers I know, right? I was just given A before. A was minus 2. It is 1. It is 3. I now subtract both of those two coordinate points. 2 minus minus 2. That is going to be 2 plus 2. That gives an answer of, I'm going to squeeze this in, that's 4. 3 or negative 3 minus 1, that gives negative 4. Minus 5 minus 3 gives negative 8. Okay, so I found this vector. I do think, generally, when we have all these common factors, good practice, it's good to recognize common factors exist in maths. We love common factors, right? So I can take a common factor out the front of everything. I can take out the value of 4. That means I have, from A to S, I've got 4 outside of 1, minus 1, minus 2. Okay? Part B says, use a property of parallel vectors to verify AS and the normal vector are parallel. Well, I have done that. I've actually pretty much done that in part A, right? It was, okay, so you can see here, vector n, this is why it's good to take out common factors. You can see these things a little bit easier. Vector n is 1 minus 1 minus 2. When I take out a common factor, I get 1 minus 1 minus 2. So it's the same vector, right? It's scaled by a factor of 4. So I can simply just say, now, vector AS, let's just make this really, so they can never take marks off. 1 minus 1 minus 2. So therefore, vector AS is equal to k multiplied by vector n, where k is like our scalar quantity. In this case, it's 4 times vector n. So I can say, therefore, AS is parallel to vector n using the properties of parallel vectors, which says that essentially, yeah, if I take a common factor out and get the same vector, they're parallel. We can have alternating gradients to get parallel as well. That's also worth pointing out, right? If I could take a negative 4 out, get the same vector, it still counts. So Wow, that is only the first two questions. So you can see, like, if we're not prepared going into the exam, the time can run away from you a little bit, right? Question 13. Question 13. It is complex numbers time. Okay. It's complex numbers. Sip louder.
Yeah.
If I'm sipping too loud, someone will tell me, right? No one's told me that I'm sipping too loud.
I am.
You are telling me I'm sipping too loud? Alright, so I need a good stylus for my laptop for maths. What are you using? Well, I'm on an iPad, so I have a good old-fashioned Apple Pencil and an iPad that I'm scribbling on. So, okay, sorry, I have to think about this. My brain just took a little bit of time to buffer there. Z equals A plus B. Okay, yeah, that's all pretty standard stuff. A, B, C, D are real numbers. Pretty standard. I've got the magnitude or the modulus, because it's complex numbers. The modulus of Z minus W squared equals the modulus of Z squared plus the modulus of W squared minus 2 times the real parts of Z times the conjugate of W. Okay, divide and conquer time. We've got a lot going on here. Sometimes these really, like, they come out so beautifully that it's really, really satisfying, and I'm hoping that's going to happen this time. I understand when you get questions like this where there's, like, a lot happening, and you have to kind of read and have a little bit of a think. The first decision we need to make is, do I start with the left-hand side, or do I start with the right-hand side? Sometimes you need to do both. I normally say start with the right-hand side, okay? We can do that. I don't think it's going to matter for this question, just what I know about complex numbers. But again, if we want to come into questions, like what's a good system I could use in the exam, normally the right-hand side's better. It's normally better to start with the messier side, because the messier side sometimes will work back and become more simple. It's harder to make the simple side look messy. That's like normally a rule that works. We'll see if it works this time around. Because I've said it and we're live, it's not going to work. But like in theory, best laid plans and all that. I don't know why my R's so curly, but my R's very curly. So let's start my right-hand side. My right-hand side is the magnitude of Z squared plus the magnitude of W, or the modulus, I should say, sorry, of W squared minus 2 times the real part of Z multiplied by the conjugate of W. Okay? So let's just substitute in. Sometimes we can do these very theory-based. Sometimes it's better to substitute in. A common question I get is, when do you know to do which one? And most of the time it kind of doesn't matter. I would say for the simple familiar questions, more often than not, we're substituting in. Anything that's like a bit CF, CU, knowing some of the theory around these is better. But we're just going to sub in. I think it's like pretty safe normally to sub in with the lower questions, and you're always going to gain some marks. I'm going to leave a line to make it a bit neater. If I substitute in, I get A plus BI. And then we used C plus DI, right? These are all pretty standard, right? It's A, B, C, D. They've just picked the first 4 letters of the alphabet to do it. So I get minus 2 times the real part of... let's just write it out. Let's not cut any steps out, because we're teaching really, right? Let's not cut steps. Okay, I get this. Just substituting in. Keep it simple, right? Start with the right-hand side. Bam! Chuck your numbers in. I'll zoom out so we can see everything I've done here. You get this. Now we start to simplify. I should know the modulus of a complex number, and I'll scribble this in case you didn't know, okay? If I have the modulus of Z, that is equal to the square root of A squared plus B squared, okay? The I parts essentially disappear. I'm just left with my real part squared plus my imaginary part squared. If I square this, well, I square a square root, the square root disappears. I get just A squared plus B squared. We're using that idea here with this, okay? We're using that idea to get, in this case, A squared plus B squared. Same idea applies to C plus DI. I get plus C squared plus D squared, okay? So I've got rid of my moduli. C minus DI, interesting. I've got rid of my moduli. I now have minus 2 times just the real bits, okay? If it's just the real bits of these numbers here, then when I do my expansion, when I expand all these out, right, I can use FOIL, I can expand everything out, okay? I'm going to wind up with just my real parts of all of that. So I'll try to put this small so we can save a little bit of space. I want the real parts of. That is going to be A times C gives AC. Don't you need to do the conjugate? Oh, you know what? That's so true. That is so true. I need to make this minus D. Thank you. That is minus DI. That is so true. Yes, that should be minus DI. Thank you. So if I expand, I get A times C. I get A times C. I then get A times negative DI. It's an imaginary part. We're not really looking at the imaginary parts. I'm going to write it just for the sake of putting it in. I'm going to put it in red though, okay? So I get A times minus DI. So I get negative A multiplied by DI. I get BI times C. That is going to give plus BCI. Again, it's red. I'm putting it in red because in this case we don't need it, but we should expand out, right? We should do things properly. And then I'm going to do BI times negative DI. That is going to give minus BDI squared. Okay? Now, we hopefully know that I squared gives negative 1. So if I squared gives negative 1, this is a rule. Like, we might have expanded these a few times to already know what that answer is going to be in this case. I guess I may as well rewrite everything out just real quick, just to make it look neat and make it make sense. That's A squared plus B squared plus C squared plus D squared minus 2. If I consider everything that's happening inside here, okay, this here, I squared equals negative 1. This is actually going to become B, or negative BD times negative 1. That's actually going to become plus BD. So what I'm left with is 2 outside of just the real parts. Well, I don't know why that became my pencil. 2 outside of just the real parts, which is just AC plus BD. Are we happy how I got to AC plus BD? I'm worried that maybe I slightly rushed that, but I think it made sense. It made sense when I was doing it at least. Happy? I assume we're happy. I'm going to keep moving. So this is what I wind up with. I get to this line here. At this point, it's not looking like it's going to simplify down as nicely as we might want. So I'm just going to try to collect like terms, get my A, B, C, D's all together if that's possible. In this case, it's kind of not, right? But I'll just simplify things down, get my squares, get my real parts. I wind up with A squared plus B squared plus C squared plus D squared minus 2AC minus 2BD. And there's really nothing I can do at this stage to simplify nicely. At least nothing I can see that's obvious and going to be somewhat easy. And again, it's a simple, familiar question. So I've got to this point here, okay? I'm now going to put a pin in it. I'm now going to consider the left-hand side. If I consider the left-hand side of my equation, that was the modulus of Z minus W squared, okay? If I do Z minus W, that is A plus BI minus, I'm going to use some brackets, C plus DI, use brackets, all squared. Okay? If I collect, expand, all that normal stuff, I wind up with my real parts are going to be A minus C. My imaginary parts are going to be, I guess I can bracket to show that's the real part if that helps. My imaginary parts are going to be B, sorry, it's going to be plus, it's going to be B minus D, all outside of I, that part's going to be all squared. Doing the same thing I did before, that winds up with A minus C squared. Remember, it's the real part squared. The whole real part in this case is A minus C. I get A minus C squared. Plus my imaginary part squared, that is B minus D all squared. Okay, so I get A minus C squared plus B minus D squared. Again, the I parts disappear because we are doing the modulus squared. So if I now expand everything out, I get A squared minus 2AC plus C squared, and then on this side I get plus B squared minus 2BD plus D squared. Well, this is very good news, because this and this is exactly the same thing. We can rearrange or reshuffle it to make it look a little bit more similar, but this is the exact same thing, which means I have a situation now where I have my left-hand side equal to my right-hand side. I've demonstrated that. Q to the E to the D. And I'm done. I'm actually done. That's it, right? So, like, for some of these questions, like I said, I normally say start with the right-hand side. Sometimes it simplifies beautifully, and you get the left-hand side immediately. This question here, I got a little bit stuck in, maybe... Stuck is a word we could use, right? Where I wound up at a point where I had a squared plus b squared plus c squared plus d squared. There was no common factors. There's nothing obvious for me to do. We have the same name. We do have the same name, Evan Kirkopoulos. We do have the same name. And that means that we are just very fortunate. We're very fortunate. So, got the same parts. Proven it. Happy days. We did it. Okay. So now, I had a whole second page. Well, I think we did that pretty efficiently then, because I wrote big, used a lot of space. Again, if you get in a spot where you've simplified as much as you can always flip to the right-hand side, even with things like induction. What exam is this from? This is from the specialist maths paper in Australia. Yeah, so like I said, even it's the Queensland one, if that helps, if you really want to know all the way down to the state. Even if we get in a spot where we don't know what the next step to do from an algebra standpoint, we can go ahead and swap sides and see if we can make things get to the same point. So, we probably have time. I would say we have time for probably one more question. Maybe we'll come back. Maybe I'll come back and I'll do another live where I finish off this paper at a later date. In part, I wanted to test out how all of this looked with sort of streaming it through onto TikTok through my computer and see how that worked. So hopefully this has been good. You guys have learned some stuff. I'm going to come back live and finish this paper off. So if people want to see me finish the paper, make sure you follow. It'll notify you when I go live. It'll allow you to come back and see the conclusion of the paper, ask your questions. I know people asked about trig dilations. We didn't quite get there today, but we will look at questions like that. So again, if you have math-specific questions, feel free to follow. Jump into the live, ask questions. I answered a ton of people's questions throughout the live today as well. So hopefully people who ask questions feel like I answered them well. And again, you can always just keep asking me if you feel like I need to explain more or you need some more assistance. If you need help with mathematics, like I said, follow. That would be fantastic. It'll notify you when I go live. I'm going to be doing methods papers, specialist papers. I will just do random lesson workshops where we'll just go deep into a specific topic and we'll cover everything from A to Z on something like logarithms or sketching graphs or calculus or integration specific stuff. We do integration by parts, integration by substitution. We can even do foundation mathematics. So feel free to follow. Again, thank you guys for those that jumped in the live. Thank you for the 3.3k likes. Much appreciated. I hope you guys all learned something. That is the goal from this. And I'll go live again soon. I'm going to go live tomorrow, definitely. We'll see how we go if I come back later today or not. But like I said, follow. You'll be notified. You'll never miss a live. And I'll see you guys. Well, I'll see you guys on the next live. I have to figure out how to end this now. I've just done that whole outro. And how I end this is still slightly a mystery. I think that should do it. Maybe that should do it. Let's see if that worked.